Welcome everyone to Ask the Experts. I'm Tim Messagy, and today we're going to be talking about PUF-based security. And I am joined by my expert, BongHo Kang, who is the Chief Technology Officer at ICTK. Welcome, BongHo.
Thanks, Tim. Happy New Year, and you have been doing well.
Happy New Year, BongHo. Thanks for
Mhm.
joining us. Why don't we kick it off with this question? BongHo, tell us a little bit about your background and how that led to the founding of ICTK.
I have over 25 years experience in the ICT and the security industries, where I've had the opportunity to lead innovative projects and deliver impactful solutions. My career began at SK Teletech as a protocol developer, where I worked on cutting-edge technology for Sky brand mobile phones. I have joined Korea's first roaming test in the United States and developed the country's first H.264 video call service. During this time, I also gained hands-on experience with the Qualcomm chipsets and their trust zone technology, which became the foundation of my expertise in hardware security. At Cisco Systems Korea, I managed many projects, generated significant revenue, and pioneered the world's first cardless conditional access system. I led the transition from smart card-based card system to security chip-based card systems, successfully deploying this groundbreaking solution to over 1 million set-top boxes in Korea within a short time. Additionally, I gained practical experience using Cisco's private HSM in both smart card and cardless system, deepening my knowledge of security key management. Later, at eStorm and SGA, I expanded my expertise in IoT and secure authentication, achieving FIDO certification for secure systems. This experience directly contributed to ICTK securing its own FIDO certification after I joined as a CTO in 2020. Since joining ICTK, I have led the company's successful IPO in 2024 and spearheaded the development of innovative semiconductor and security solutions. My journey has always been about pushing boundaries and using the technology to create global impact.
Thank you, Bongho. At the outset, I said we'd be talking about PUF security. Explain for us what is a PUF and what function does it perform?
A PUF, or physically unclonable function, is a hardware-based security feature that uses unique physical characteristics of a semiconductor chip to create kinds of a fingerprint. These characteristics come from tiny variants in the manufacturing process that almost cannot be copied, even if the same design is used. This makes PUF technology extremely secure because they almost cannot be cloned or tampered with. The main job of PUF is to generate secure, unique cryptographic keys without needing to store them permanently. Instead, the keys are created on the spot when needed, which makes it much harder for hackers to access or steal them. This is why PUF technology is widely used in applications like device authentication, data encryption, and secure communication. At ICTK, we take this further by using PUF technology as the foundation for root of trust. A root of trust is a core building block of security. It is a trusted component that ensures all other parts of the system operate securely. By embedding PUF technology into chips, we guarantee that cryptographic keys and the authentication processes are both unique and resistant to cloning or hacking. For example, ICTK's VIA-PUF technology directly integrates this root of trust into our hardware. This enables secure device authentication, encryption, and even protection against the emerging threats like quantum computing.
BongHo, you mentioned VIA. Tell us how the ICTK puff is implemented, and is it different than other puffs that are available on the market?
ICTK's VIA-PUF is a standout security solution known for its exceptional stability and reliability. The key feature of VIA-PUF lies in its use of passive components, specifically VIA structures. These passive components are highly resistant to external factors such as noise, aging, and environmental changes, which makes VIA-PUF far more stable and reliable compared to other PUF technologies. While many PUF technologies rely on complex error correction mechanisms to ensure stable outputs, VIA-PUF minimizes the need for such processes thanks to its robust concept. ICTK not only applies advanced techniques to optimize performance further, but also the VIA-based architecture significantly reduced the unnecessary complexity. Another major strength of VIA-PUF is that it has been proven in real-world applications. ICTK has manufactured and distributed over 15 million VIA-PUF-based chips, showcasing not only the technological excellence of our solution, but also its reliability in diverse environments. Each chip has undergone strict testing and has been successfully deployed in systems, requiring the highest level of security. Additionally, VIA-PUF complies with the ISO IEC standards, ensuring it meets global benchmark for security requirements. It is also easy to integrate to a wide range of products and systems, including IoT devices, cloud services, and mobile networks. In summary, ICTK's VIA-PUF combines strengths of VIA structures with precisely designed processes to deliver unmatched stability and reliability. It is not just a theoretical concept, but also it is a proven technology that provides a robust security for the connected system of today and tomorrow.
Thank you, BongHo. Okay, so let's say I'm a designer. What do I need to worry about? What are the design considerations I have to think about in terms of implementing the ICTK puff? Do I have to worry about, is it available at this foundry or is it available at this process node? Can you talk about those issues?
From an engineering perspective, implementing a VIA-PUF involves several key considerations that makes it both practical and secure. While it shares many similarities with other PUF technologies, VIA-PUF also offers unique advantages and requires some additional attention. I would like to say four things. First, process node selection and validation. BFUP has already been successfully implemented and validated on specific process nodes. For these validated nodes, no additional testing is required, making it easy and faster to integrate into products. Second, post-processing for enhanced security. Although VIA-PUP is stable itself, applying additional post-processing mechanism can help further strengthen security. Techniques such as pre-selection, freezing, and hiding techniques ensure the PUF outputs meet the highest entropy and the security for cryptographic applications. Third, cryptographic design considerations. When implementing via PUF, it is essential to consider how it will be used in the final applications. For example, determining how the PUF will support cryptographic functions like encryption and authentication, or how many key derivation functions will be needed. It should be planned during the design phase. This ensures the implementation aligns with the security needs of application. Fourth, protection against non-invasive attacks. As cryptographic systems face the increasing threat from non-invasive attacks, like differential power analysis, engineers must implement additional countermeasures. While VIA-PUF itself is highly resistant to invasive attacks, cryptographic algorithms that use the PUF-generated key requires extra layers of protections. Techniques such as masking, balancing power consumption, and introducing noise can effectively reduce vulnerabilities to side-channel attacks while also enhancing the overall security of the system. For this type of advanced security, Rambus is the ideal choice.
BongHo, let's step back and talk about, the context that all of this technology exists within. Talk a little bit about the threat environment and how that's evolving and what we need to worry about for electronics going forward.
The modern threat environment is increasing, alarming, especially with the sheer number of connected devices that now play a role in our daily lives. These connected devices, while convenient, can also pose significant risks. For instance, there have been cases where a simple walkie-talkie was turned into a bomb, illustrating that even IoT devices could potentially be weaponized against us. This highlights the critical importance of device authentication and the component verification to ensure every part of a device is trustworthy. This need for trust extends into a supply chain, particularly in securing a hardware bill of materials, HBOM. Supply chain security has become a major focus, as ensuring the authenticity and the integrity of a component is essential to protecting the overall system. We are also seeing a significant shift from software-based security to hardware-based security. One of the key elements of this transition is rule of trust, which acts as the foundation of a secure operation in devices. Companies like Rambus has developed some of the most respected silicon IP for rule of trust globally, setting the standard in the field. However, enhancing and maintaining the strength of this rule of trust relies on advanced technologies like PUF. PUF technology plays a critical role in creating a chain of trust, allowing connected devices to defend themselves against hacking attempts. By securing storing cryptographic keys or generating keys for secure communication, PUF helps build a strongest possible security architecture. It ensures that the sensitive operations, such as encryption and authentication, are performed in a trusted and tamper-resistant manner. In today's world, where cyber threats are evolving rapidly, technologies like PUF and robust supply chain security are indispensable in protecting both individuals and organizations. They ensure us to confidently leverage connected devices without compromising safety and security.
Thank you for those insights, BongHo. BongHo, how can people learn more about ICTK and your PUF security technology?
Thank you, Tim. Thank you, everybody. for the opportunity to share more about ICTK and our work. If there is one key message I'd like to leave with you, it is the combination of ICTK's via PUF technology and the Rambus's world-class root of trust represents a transformative step in hardware security. Together, these technologies create a robust foundation for securing connected devices and protecting against the growing threat in today's digital landscape.
Great. Thanks, BongHo. And if folks are interested, we've also got a webinar with BongHo and Rambus's Scott Best, where they talk about the ITCK PUF and the Rambus Root of Trust and how those two solutions can work together. With that, thank you, BongHo, and thank you everyone for joining us. We'll see you again here on Ask the Experts real soon.